Welcome to our exploration of the role of deep learning in modern data mining. Deep learning has transformed the way we handle and analyze big data. It's a subset of machine learning that mimics the human brain's processing capabilities. With deep learning, computers can learn from vast amounts of data, revolutionizing data mining. Businesses and researchers rely on deep learning to uncover hidden patterns, informing strategic decisions. These models process and analyze data at unprecedented speeds, enabling real-time analysis. Traditional data mining techniques struggle with large, unstructured data sets. However, deep learning handles this complexity with ease, making highly accurate predictions. This predictive power is invaluable across various sectors. Now, let's delve into the key concepts: neural networks, algorithms, and training data. Understanding deep learning begins with neural networks, the backbone of these technologies. These networks consist of interconnected nodes, similar to neurons in the human brain. Each node processes part of the input data, and the network learns by adjusting connections, a process known as training. Algorithms guide how the neural network learns from data. Common algorithms like backpropagation and gradient descent minimize errors during training. Training data is essential for deep learning. Without it, the network cannot learn. The quality and quantity of training data directly affect the model's performance. More diverse data generally leads to better accuracy and generalization to new examples. This interplay of neural networks, algorithms, and training data makes deep learning exceptionally powerful. Moving on to the applications in healthcare. Deep learning has made significant strides in the healthcare industry. One major application is in medical imaging, where it can quickly and accurately identify anomalies, leading to early disease detection. Precision medicine benefits from deep learning by predicting individual responses to treatments. This personalized approach improves patient outcomes and aids in developing new treatments. Deep learning revolutionizes drug discovery by analyzing vast databases of chemical compounds, speeding up the identification of potential new drugs. It also helps manage healthcare data, improving hospital operations and resource allocation. Hospitals generate massive amounts of data daily, and deep learning can process and analyze this data efficiently. This holistic approach enhances the overall efficiency of the healthcare system. The impact of deep learning in healthcare is profound and continues to grow. The finance industry has embraced deep learning for its predictive capabilities. One primary application is in fraud detection, where traditional methods often fail. Deep learning models analyze transaction patterns in real time, identifying unusual activities instantly. In algorithmic trading, deep learning optimizes strategies for higher returns and lower risks. Customer service has improved with deep learning-powered chatbots handling inquiries efficiently. Deep learning also enhances credit scoring, analyzing a wider range of data. The finance industry benefits from deep learning's ability to process vast amounts of data quickly. The future of finance with deep learning looks promising. Deep learning has spurred numerous advancements in data mining. Convolutional neural networks, CNNs, process visual data effectively. CNNs are used in image and video analysis, with applications in security and entertainment. Recurrent neural networks, RNs, improve speech recognition and predictive maintenance. Transfer learning allows models to apply knowledge from one domain to another. Advancements in GPUs and TPUs boost deep learning capabilities. These advancements enhance the efficiency and effectiveness of data mining. The future of deep learning in data mining holds immense potential. One promising area is unsupervised learning, which can uncover patterns without explicit labels. This ability opens new possibilities in data exploration. Integrating deep learning with other technologies like quantum computing could revolutionize data processing. Quantum computers handle computations much faster than classical ones, expanding the scope of data mining. Ethical considerations will shape the future of deep learning, ensuring privacy and fairness. Developing transparent and interpretable models will build trust and encourage wider adoption. Ongoing research and innovation in deep learning will drive progress. As algorithms become more sophisticated, the accuracy and efficiency of data mining will improve. This evolution will unlock new insights and opportunities. The journey of deep learning in data mining is just beginning. Its future looks bright with endless possibilities ahead.